I have worked in machine learning and AI for over 25 years. It's been a really wonderful journey. I love, helping teach computers to communicate with people, and every point in time is unique. In AI right now, the biggest challenge that we have is data quality. So much more information available to learn from. And that's what AIs are struggling with today. They're learning from AM. If you want to know what living in a hyper-intelligent world might be like, ask a dog for its relationship to a human. We support AI both in the data as well as the tooling that it can have access to. You take your accuracy performance from 50% to over 80% when you introduce a knowledge graph. You need a system that is massively concurrent. It's very high performance, that's responding in milliseconds, because we're making decisions, we're taking actions. We've built a system that is designed to describe everything, store it efficiently, and retrieve it very efficiently.
I'm Dave Ross, and we're at Point of Data's headquarters, and I'm going to be talking with their CEO, Chris Schindler, about the business side of the company, as well as some of the technology side that he's been involved in from the very beginning in artificial intelligence. Tell us a little bit about your background.
I have worked in machine learning and AI for over 25 years, working with Microsoft early on and learning there and having a great time in speech recognition and text-to-speech synthesis, and then spent 10 years at Amazon building the original Alexa product, working on natural language understanding and paralanguage understanding and some other aspects. And then most recently with a Gen AI company out of the Bay Area. So a long history of being an engineer within machine learning as well as a scientist, as well as managing teams and being a product thinker there. So it's been a really wonderful journey. I love helping teach computers to communicate with people, and I've been very lucky in my career.
What attracted you to Point of Data?
What attracted to me to Point of Data is this very simple idea that Stanford and I, one of the co-founders, talked about very early on, which is every point in time is unique. And it matters because it's the building of context. And so to understand something beyond just a fact, but to understand a piece of data or an event, that context needs to be there. And at the time that I started talking with Point of Data, I was thinking a lot about context and what that means and how it flows. And when I looked at their technology and the underlying principles that Mike had built, I realized that this was a platform and a system that was built to capture, process, retrieve context. And when I think about its application to AI, the connection was immediate for me. It's like, this is outstanding. How can I help?
How does it fit most with AI as my audience is most interested in AI? Meaning what they read about with ChatGPT and with Microsoft and all the others. Sure.
So in AI right now, the biggest challenge that we have is data quality. And to illustrate this, I give an example. In the 1950s, music went through this revolution, building upon some inventions from the World War, where the listening experience went from an AM radio to a high fidelity system in your living room, and it went from scratchy, thin sounds, mono, to a concert. And it was this fantastic experience for the listener. Now imagine we have an AI that's trying to learn how to play music. And it's listening to AM radio. And it says, okay, this is what music sounds like. This is fantastic. I'm going to emulate that, right? Well, what you get is AM music. If you took an AI and said, learn from this hi-fi system, well, you're going to get much greater dynamic range. There's this notion of stereo. You've got many more harmonics, sorry to be so technical, but so much more information available to learn from. And that's what AIs are struggling with today. They're learning from AM, right? And so we see a data quality in the richness, in the tapestry, if I can mix metaphors here, to learn from is thin compared to where it needs to go to achieve the promises that we're making as an AI industry, 5 years out when it's going to be a $30 trillion market. And so what we're really thinking about is how do you capture high fidelity context to bring in the music, the music example, and of all those different pieces so that I as an AI can much better train and achieve goals, particularly as we take a look at things like agentic investments where I need to understand a lot of different components that are changing potentially very, very rapidly, and just a fact is not going to get me what I need.
Right. That is completely understandable. Do you run into the "we're all going to die" approach to AI that I run into all the time? But I'm looking at the other end. I'm looking at the output side of AI. You're looking at obviously the input side of it. Do you run into that? Absolutely.
And I think there's several easy entries into this. The first one is this notion that of a hyper-intelligence, right? And there's a quote that I heard recently that said, if you want to know what living in a hyper-intelligent world might be like, ask a dog for its relationship to a human. And, there's a lot of fear that comes into AI without a lot of understanding in my experience. So we hear it around biases, and these are real problems, but biases within the data that we're learning about. Biases that then translate into the training. Those are all challenges, but what we have to keep in mind is what are the goals that we're using to train the AIs? Because that's the Rosetta Stone for what's happening here. And so I don't fall into the camp of the sky is falling in this particular case. However, I am very aware of what are we teaching these things? And what are the source materials? What's the data that they're using?
And who's teaching them?
And who's teaching them using what principles? And so that's where I think the more useful conversation comes in. It's like, okay, what are we teaching? How if we're asking these AIs, particularly agentic AIs, to make decisions and take action in space. I'm sorry, I don't mean outer space. I mean within action space. By what principle are we telling it to act? And how are we evaluating it?
Which brings up a question I have for you, and one that I've thought about quite a lot myself, is how do you teach ethics to an AI? Because that's what you want. I mean, how do we teach our children to do the right thing? We teach them right and wrong.
We teach them right and wrong, and that comes from the source materials.
Mm-hmm. Yes.
It also, I think, comes in. Let me back up for just a moment. One of the things that I think about a lot, and it gets to your question, is what is the goal that I'm setting for an AI that I want it to learn, right? When I say go do something, and I want you to do this really, really well, creating a well-crafted goal is actually extremely difficult because you end up running into the law of unintended consequences.
Yes. Oh, gosh.
Exactly,
yes.
Right? And so, there have been projects in the past that we know of where they said, okay, we're just going to turn on chat and it's going to learn from Reddit and everything is going to be golden, and you get a bigoted, biased, such all the things racist interaction because of the source material that we taught it and the goal that we gave it, right? And so coming back, I think a lot about what is the goal that we are asking these AIs to act upon and learn from. One part is the source data, teaching ethics, right? What is an ethical set of data? And being very clear about the biases that we are bringing in to our assessment of ethical. The second part that I think about a lot is what's the feedback loop? Because our AIs are taking actions and doing something, and they need feedback. Was that in line with how I want you to be acting, or is that out of line? And here's why. And part of the AIs that we're building, particularly right now, with LLMs and reinforcement learning and layers and so on, part of their job is to make stuff up. And I think that's what a lot of people don't realize is they're testing boundaries.
Well, it's even more than that when you're doing agentic AI, because it has to be making things up in order to fulfill the sub-goals.
Exactly. And so that both having the source data in a rich enough form that you can do something useful with, but the feedback coming back in, I think both parts are required for an ethical AI.
Mm-hmm. I think you're absolutely correct. What worries me about that is, I get the silly question of whose ethics. I'd say almost anybody's is better than none, but people are not yet really thinking in that direction. So let's go back to point of data on this. What does point of data bring to the AI industry?
So the first thing that we bring is the ability to capture high fidelity context.
Mm-hmm. Okay.
Mike talked about we have an extremely efficient neural memory database that we've built, which is designed to capture that, interrelated at a much richer level than other products available in the marketplace, and then be able to search that usefully. I'll give a contrasting example. A vector database is something that we often use.
Sure.
You describe data using a bunch of numbers, and then you get a query in, use that same description to go search those vectors and say, okay, there's something close here, I'm going to grab this. This must be related. But it's not very flexible. It's very version dependent on both sides. It doesn't it uses distances and other things to say these two things are related, but they actually might be a weak relation, and it just happens that the math worked out that they're close by, but that doesn't mean there's a semantic connection. And so part of what we built is the ability to interrelate data at a much richer level than, for instance, a vector database. So that's point one. And of course, we talk about that's also done with extreme energy efficiency. On a power optimized device, we have a bench that we run that shows that for the same data performance, you can get the same performance on hardware that costs 50% less and uses 75% less energy, which is dramatic.
Yes, especially as you get to very large data sets.
Right, and so we talk about data quality, but there's also the cost aspect of that. And then Mike touched on the encryption capabilities of our system and not incurring extra cost to protect that data.
Yeah.
So that's the first one. The second one is that the way that we architected the system was to be a concurrent system that uses distributed resources. So it was designed to be very high performance. The implementation of that means that we can bring any other piece of software into an ecosystem of actors. And an actor just represents any software system. It represents our neural database, neural memory database, but it can represent anything else. And that's an important point because when you look at Agentic in the marketplace today, the solutions out there, be it LangChain, Microsoft, what have you, they're focused on an LLM going through a pipeline of decisions and reasoning to accomplish some goal.
Mm-hmm.
What it does is it locks out all the software that our businesses are running on today.
Right,
that's true. So if I'm an AI and I want to be managing a supply chain, for example, for a manufacturing company, I need to know what's the performance of the manufacturing machine. When are these shipments going to be coming in? For what volume? I need to know a lot of information about the business. What's the commodity markets, right? Mm-hmm. To be able to make useful decisions, and the intelligence are built into tools that are not available within this agentic space. And so what our system does is, one, we can capture the data that we've just been talking about and do it in a very rich, powerful way. But second, we unlock any legacy software as well and make it very simple to communicate with. So we support AI both in the data as well as the tooling that it can have access to.
That makes absolutely perfect sense. You're now, of course, going out and turning a prototype and a prototype company into a real and a real.
Yes.
How are you going about the issues of raising money, because that's the only way you're going to do this, and how are you going about that?
So the first step that, of course, we've been talking about is describing the problems that we've been conversing about, the data quality challenges, the cost challenges, encryption efficiencies, and showing how our platform fits to solve those particular challenges. As Mike was talking about, we're building shovels, right? And we're building a platform for scientists and engineers to use to go solve their particular problems. And so when we go raise money, we're showing this is the platform and how we solve these particular problems, but there's a crucial step here, which is how are the engineers and scientists going to use it? And so the first product that we're bringing to market is a engineer and scientist facing website that allows them to spin up an actor and get a neural memory database within 5 minutes. So, taking a step back, when I would take on a program as an engineer and a scientist, the first thing I would do is say, okay, what problem am I trying to solve? And often it was around, okay, I have a lot of data that's going to evolve very, very quickly, both in its schema as well as how much I'm collecting of it. I start looking around for tool sets. And that's the point at which we're going to be engaging with scientists and engineers and saying, we have a website which manages this for you. It sets up these actors, it manages it. It's going to make it very easy to scale, migrate, do all the things that we would expect as engineers. And we do it point and click.
Now, where engineers are chronic for not being the ones that sign the checks, how do you sell this to the companies themselves?
Sure. So first off, we have a freemium product. So the entry is free to use.
Okay.
So you say, okay.
That's a good price.
That's a good price. Try it out, see how it works. When I'm, again, coming back to an engineer using this, we are looking for certain characteristics. How quickly can I evolve this? How easy is it for me to use inside of my code and to implement? How easy is it for me to scale and manage once I am, once I'm in a deployment phase? So we look at those pieces. But the second part to your question is we're also very upfront and transparent about how we bill for the usage of that platform. So you prove it out using the freemium product and say, yes, my prototype works. We want to take this. We have tools to say, okay, this is what it's going to cost you. The second part to that then is when we go talk to the people who sign the checks is that the more you use, the less we charge you, right? And so we want to have this behavior where you're using the system, you're storing more data because you need the richness to retrieval augmentation for your LLMs, if you will, or as an example, and training data. Whatever data you need, we want to encourage you, and so we economically make it. The more you store, the less it costs you. And we make all of those charges very transparent, so you don't get a surprise bill at the end of the month. The second part of that then is that we want to help you model your growth, and so we provide tools to help you model that as well.
How do you present this to investors? You're about to do that. How do you do that?
So again, we talk about the problem set and the solution set, but then we take it to a concrete place. And so one of the examples that I use is a restaurant business, right? And so I have a restaurant AI that's like Church's Chicken or something like this, and I want to have an interaction, right? And we say, okay, a customer might say something very obscure about ordering from that particular menu, something that's not a keyword from their menu. And so they would use our product then to store that context, so that if I say something like, I want, I'm trying to come up with a quick example here, but maybe it's a burger joint, and I want, I want some, ground cow with some pig on top, and leave the garden behind, right? That's a use case where we can show in our demonstrations, here's the basic techniques that are available today, but when you add in the richness that we're talking about in the high fidelity context and say, okay, there's a lot of different ways you can describe a hamburger patty, right? So we give them a specific use case. We also show them how easy it is for an engineer and a scientist to go create and prototype and get the code running, and then how easy it is to scale.
And that context is built into your technology at the very most basic level, as
Absolutely,
I understand it.
Yes. So we think about two different types of context. One is explicit context, where I add some metadata that I think is interesting, right? But there's also implicit context, and that's really where our platform shines, because it will take time and location as an example and say, okay, I'm automatically going to start pulling these things together based upon when something happened. And I'll give an interesting example here. The difference that context makes is if you take a fact like the Berlin Wall. The Berlin Wall coming down was triggered by a press release and a press conference in East Germany. That's a fact. We can put it into a database and we can retrieve it. If you asked an AI why the Berlin Wall fell, right, it might regurgitate that fact and be correct, but it's missing all of the context, the socioeconomic, the political, right, the timing of everything. And so, as an example of how we build context, we implicitly know about events that are happening together, both in time as well as location. And we also take those explicit values and start to relate them together for you as well. And so this is the bare metal of what we build for the engineers and scientists. And then we have an extremely flexible system to describe data as well as interrelate it, and so link it together. As Mike said, this is part of our system is a graph database. It takes a node, it can link to any number of other nodes, it carries weights, and so there's information now that begins to express in context that you can return back. And that's where we take something like my restaurant example, using an off-the-shelf retrieval augmented generation, or RAG solution using a vector database. It's proven that you can take the basic implementation for that, and this is actually some Microsoft research that was done a year and a half ago, 2 years ago. You take your accuracy performance from 50% to over 80% when you introduce a knowledge graph.
Okay.
The difference is those relationships and interrelating them, and that's what we support straight out of the box.
That is an impressive advance at the data entry level, let's call it that.
Absolutely.
What are your prospective investors typically investing in today?
So the people that we're talking to in the investment community are focused on infrastructure, because they recognize that there's a paradigm shift happening right now, and it's being driven by agentic AI. And that is, I want a system, I'm going to build an agent that's going to help me run my business better. It's going to take over some tasks in collaboration with people. It's going to do something for me. What that means is, and we touched on this a little bit earlier, is that those agentic AIs have to have a lot of tools everywhere. It's not just within necessarily my business. It might be across multiple divisions of my business. but I might be relying on stock market stream information or commodity market stream information from a completely different piece. And so the people that the investors that we're talking with are looking for the infrastructure that is going to drive AI and help it achieve the promises that are going out there. And we look at these agentic AIs and say, okay, you need a system that is massively concurrent, that's very high performance, that's responding in milliseconds, because we're making decisions, we're taking actions. It also has to be asynchronous. We can't have these tight couplings in between these systems. And so where we're finding traction in these conversations is, okay, let's bring it back up to the top level. We've built a system that is designed to describe everything, store it efficiently, and retrieve it very efficiently, right? And it's protected, and it's going to cost you less, right? And we provide an infrastructure that simplifies the development experience, because all of the actors that we've talked about here, whether it's our neural memory database, or it might be an IBM mainframe over here, the messaging is standardized to one messaging. Mm-hmm. And so it becomes a much easier implementation experience for the engineer and the scientist, frankly. And so we find the companies say, okay, you've got the unit economics nailed. You've mm-hmm. got the memory, the neural memory design that's going to scale to petabytes of data on low-cost hardware. We've got a great solution that people can then build on, and that's what's going to take these AIs into the next a step function of capability, is providing that data, providing those tools in a simple, easy-used framework that scales extremely easily.
How does the use of AI, especially agentic AI, within your system work? I'm not saying using yours for that. I'm saying using it within your system. For example, I'm working with a new system for a customer that has to pull in data from a bunch of places I've never pulled data in before. It'd be very nice to have within your system an agent that can figure out, I need this, I need this, I need it in this condition, I need to change it into this format in order to store it properly, and so forth. Yeah. Have you given thoughts about that direction?
We have, absolutely. So 2 comments there. The first one is our code base that is open source and is released has a set of AI prompts to teach an AI or an LLM how to use our system. Oh, that's fantastic. Right? And so you can say, okay, I have a new data set. I want you to here's some natural language, description of what I want to be able to do with this data set. Use this other source material to create the event objects in the linkages and go do that work and put it into the database. So we provide tools to help both structure the data as well as how to communicate with the neural memory database and how to search it, which is an important aspect. The second part is part of the services, and we haven't talked about this yet, but the actors that we create and that we enable also form into a marketplace of actors. And so we are providing, just straight out of the gate, we are providing the ability to take your data set, your text data set, and create a knowledge graph and put it into the database for retrieval augmented generation. So you immediately get that performance jump that we were talking about earlier. So we provide that as a service mm-hmm. That you can use straight out of the box. If you're looking at data migration or just net new data, whether that's coming from IoT devices or wherever your data required for your business comes from.
How do you handle, I'll call it conditional data that you have, but you only have a questionable view of its accuracy? That doesn't mean you know it's wrong. That's not what I'm saying. I'm saying you really don't know how good the data is, but you want to be able to use it. Do you have any way of handling that within your system? Or is that at a higher level?
That's at a higher level. We look to the scientists to understand and work, with that data. That's their private data. They know what they need to do with it, how they're collecting it. We provide the tools to store it and work with it in a very efficient manner.
Okay, that makes perfect sense. Mike said that, of course, the first people you're going to go out and hire is a bunch of engineers to help realize things. What are they doing now? What are the people you would be most interested in hiring once you get financing closed? What are they doing now? Besides being frustrated with, he was talking about.
They are thinking very critically about how these systems are reasoning and interrelating data. And, Mike talked a little bit earlier about we've built something which is extremely flexible and is built to go solve difficult problems. And when I say difficult, things like reasoning problems or the interrelating of data, how do you continuously update data and learn from it? Like, we don't think of data as a static place, and this probably is obvious because we talk about context, but the meaning of data is always changing. Sure. And so this is why I come back to, we're looking for people who are thinking about the primitives and how data evolves over time, and how AI in their reasoning, whether you're using something like a transformer model or a reinforcement learning model or the other million models that we know about, even down to a perceptron, what kind of data do those systems need, and how do they need to talk to each other, and what tools do they need? We're looking for people who can clarify a problem and say, okay, I can see a problem, I don't know how to solve it, but I'm going to use a lot of critical thinking and creativity to go do that, because what we've built is an ecosystem for builders, really, and that's both data as well as process execution.
That sounds like exactly where you ought to be. What's novel about this is I deal with a lot of AI. I talk to a lot of people in AI business and so forth as part of this channel. And you are the only company that I have run into that is thinking about the problem from the basics. From the where does the data go? How does the data get organized? How is the data, when it's gathered, made most optimal for later use? Where you don't yet know what the later use is.
Well, absolutely. So one, capturing it, and say, oh, I'm going to learn from this in 2 years' time, right? I'm going to develop new techniques, or now I see that this data is interrelated in ways that I didn't understand before, and that's where AIs will also help us begin to increase the resolution, if you will, or the fidelity of that data. Say, okay, here's things that you human aren't aware of. Here's some connections, but I'm going to make them for you. And it's an incredibly thrilling time. But there's also one other piece that I wanted to talk about, which is when we think about a graph database, as an example, or a spreadsheet, or what, choose your example, it tends to be a 2D, even a graph, it tends to be a 2D experience. One of the prototypes that I built was that I actually implemented a neural network inside of our neural memory database. And so weights, biases, each hidden layers, essentially, all those nodes expressed within data, and so you get this data computational experience. The reason I think that's important is, to your point, we're going to continue to learn, and I can have a layer that says, okay, I'm going to group this data a little bit differently. Maybe I'm designing a car and how it wants to see a street. I've got all this data. I'm going to take all this raw data, but I'm going to create a new layer on top of this and a new way to express it and understand it. And so it's not only just capturing the raw data and doing it efficiently, which is what we at lower cost, but it's also being able to layer in additional understanding over time.
I mean, it's by definition, you don't know what you're going to be using your data for, because that's why you're gathering the data so that we can figure out how to use it. To be able to, what I have liked particularly about the point of data, let's just call it the nugget, the center of where the space-time algorithm about where things come with context added onto that, is the fact that it's a dynamic model. It can change with time. I mean, obviously, not only do things move, but also that what's related to what can shift, grow, shrink, and all those sorts of things. And yet, your system is organically designed that doesn't interfere with anything. It just happens.
It just happens. You know, I think embeddings are a great example. So of course, you know, we can store extremely diverse data, data types, right? A value can be, well, it can be binary, it can be anything, right? But let's choose embeddings just for a moment, of which for some of your audience is just a long array of numbers. Those numbers are tied on both sides, the input and the search. So you have to encode your input, like your query. You encode a certain word to a number, and that encoding has to match inside of whatever you're searching. For someone like me, who is changing and my embedding models are improving and I'm releasing new versions. Every time I do that, I have to go re-encode my data, and I have to make sure that I have a synced version out with my query. One of the properties of our system is that when you introduce a new piece of data, it's automatically versioned. So if I have a set of customers internally who are using my database, I can represent in search on 3 or 4 different embeddings, different versions of embeddings. And it's all just easily, you don't have to do any work. It's just built in. And so just in that use case alone, it's a lot simpler for me to use. But it's an example of the data just naturally versions. It updates itself. You can say, okay, I want the latest version, or I want a version back here at this time and location. There's a lot of richness moving, if you will, across the space-time continuum.
What does success look like to you for point of data?
Success looks like, number one, having a platform that is very easy for scientists and engineers to invent on and deploy with. And so I want them to say, okay, yeah, this is really flexible. It reduces a bunch of challenges that I experience today. And it also makes a lot of sense from a cost perspective, and it doesn't limit me, right? I'm not rat-holed into some specific JSON object, for example. I can evolve my data schema infinitely without breaking anybody. So I want a tool set, first and foremost, that is easy to use and enables them to go build the solutions that they need to for their business problems. Secondly, success for us helps them understand and interrelate that data better. So we're building a suite of tools to help them achieve that high fidelity context. Thirdly, we want to ensure and get out into the marketplace these security encryption protections. One of the things that we think about is, where is your data residing, and do you actually know where that is and who has access to it, and how do you protect it? And so encryption for us in security is a very big deal, especially when we think about this paradigm shift that's coming, where you have a bunch of autonomous agents or actors in our platform that are interacting. How do you know that you're talking to the right other actor? Right.
Yes.
Is this entire layer of security that's upon us now, not to mention the challenge of quantum that's coming down, that's arriving, right? So building all of those pieces so that our customers are successful and secure and built for the next 20 years in supporting AI and in their systems. That's what success looks like for us.
That makes great sense. And as I said, in all the work that I've been doing and looking at things in AI, I think it's a unique approach. Not only is your technology unique, the idea that you are at that level of the system, namely the data aggregation and gathering and making the data usable, is, as far as I can tell, unique or nearly so.
You know, I just wanted to interject a point there, which is, Mike touched on it earlier, but this system, both the how these actors run, as well as how they communicate, this operates on everything from an IoT device up through a high-performance, computing situation. It's the same simple architecture that drives that entire scale. So I can have a series of sensors in my manufacturing plant that's gathering the data, and it's passing it back up the chain to things that are aggregating and building more and more understanding. From an engineering perspective and a computer science perspective, it's the same pattern.
Right.
And it scales from those small things all the way up to a high performance.
And it scales as it's used. I mean, it scales as it is put into effect.
Yes.
In other words, it doesn't have to be designed beforehand.
That's right.
And that's what makes it extremely powerful. Well, Chris, thank you very much for spending the time with us today. And I appreciate Mike, you also, and good luck on your fundraising.
Thank you.
If you like what you've heard, I ask you to subscribe and comment. Thank you very much, and see you next time.